All right. So as a quick review, we need to remember a few things. We need to remember what is we need to remember that if we have a air water boundary, right, mediums of two different densities, as the wave travels from one to the next, we need to remember that what will happen again? The wave will undergo refraction, it will slow down, causing the wave to bend towards the normal, right? How much the wave bends is called the refractive index. And the refractive index was sine I over sine R. There's also a next relationship, speed in medium 1 over speed in medium 2, or wavelength in medium 1 over wavelength in medium 2. All right. The next thing we also looked at, a special angle of incidence. There's a special angle of incidence called the critical angle. That gives you an angle of refraction of how much, Ravi? Carry on. We did last week. Critical angle is a special angle of incidence that gives an angle of refraction of 90 degrees. Good. 90 degrees. So the angle is here. And the critical angle, I'm not sure if I gave you the formula. Critical angle is sine inverse 1 over the refractive index. Okay. And the last thing we did was something called, I gave you the note on total internal. And you give it a note. Okay. So I'll give you the note today on that, then move on. I gave you this last day, right? Critical angle. Huh? Oh, I didn't get it here. So write that, please. Here there is stop last day, right? So the critical angle, I'll just give you a small note here. Critical angle is a special angle of incidence. Right, so in case you don't have it, write that, please. It's a special angle of incidence that gives an angle of refraction of 90. So why? So, all right, so that's how we stopped last day, right? And this is the formula to find critical angle. Let's do two quick examples to make sure you can use it properly. All right, so what's this here now? Let's try a quick example. So if I give you a medium and the refractive index is 1.9, right? The critical angle will simply be sine inverse 1 over 1.9. How much is that? Click in the calculator. 1 over 1.9 is how much? Online, you'll get the message, right? What's sine inverse 1 on n? 1 on 1.9. How much? Steady? I didn't hear that. 31 point. Okay. Right. So wrong with the sheet the figure. 31.8 degrees. All right. That is your critical angle. Yeah. I want to make sure you can use the formula, right? Let's try it one more time. Use a refractive index of 2. Find the critical angle. Tell me what you got. Online, you're doing it there. Adele, you're doing the question. Jaya. Right, Katrina. Oh, we're just working out sine inverse 1 and 2. How much you got? 30, right? 30 degrees. Anybody not getting it? Make sure I calculate in degrees, right? Press the arrow key and convert it back to degrees. Right. What you'll notice, by the way, which of these has a larger refractive index? 1.9 or 2? 1.9, right? Sorry. Which of these has a larger refractive index? 2, right? So if you look at it there, what happens to the critical angle as the refractive index increases? As the refractive index increases, the critical angle what? Right. The critical angle decreases. Okay, so let's make a small note of that. Caleb, you okay there?
Yes, sir, I got.
Alright, nice. You can audio online, you can use your audio. Jose, you get you?
Yes, sir.
Nice. So if there's enough, it's going to pass into past papers, right? Change the color. Okay. Right. Let's take a look at something else, right? Let's take a look at something called total Oh, and come outside to change it. All right. Okay, so exit, play. Chance, right? Small chance, play. Play. Okay, all right. All right, so what is total internal reflection, right? So if you look here, let's take a look at this here. We have air and water, right? Which is more dense? Well, which is more dense, air or water? Water, right? So water is more dense than air. If I were to have, and I think I showed you all this on a simulation. But remember, there was a particular ray in the water that did not come out of the water, it stayed in the water, and it underwent reflection. That particular ray underwent total internal reflection. So the angle of incidence here was the same angle of reflection here. Of course, I is equal to R. Right? So this ray, the ray underwent total internal reflection. Right? And I'll call it sometimes TIR. Okay? So the ray underwent total internal reflection. And the reason it underwent that, two reasons. Since number one, you see that angle for I? That angle for I was more than a critical angle. That particular value, that angle was more than a critical angle. And the second thing is that the ray was in the tensor medium. So two things happen here. If you look at this ray underwent two things. The ray, that value for I was bigger than a critical angle for water. Right? And it was in the tensor medium. Once those two things happen, notice I have the word here, right? And that's a very important word. Once those two things happen, total internal reflection will also occur. Okay? So those are the two conditions that happen. If you remember the simulation from last week, there's a particular ray that didn't come out of the water, it stayed in the water. And the one that stayed underwent total internal reflection. Okay? Any angle more than a critical angle, that will happen. Okay? Copy down. You all remember this simulation? Oh, the ray was in the tensor medium. Right? So the two conditions for total internal reflection are I is more than C and the ray in tensor medium. All right, so we're trying to see if we can figure out how this thing works, right? Copy that quick. Let's try an example. What would happen if one of the conditions are met until here? What would happen if the ray is in A, but I is more than C? nothing will happen. No more refraction, right? Those two things have to happen at the same time. Ready? Change. Right answer. Go ahead. Ready? Huh? Ready? Right. So let's take a small example. Anybody writing online? Caleb again today.
Yeah, yes, I finished.
All right. So let us start with example 1. Right? Let's use the refractive index of water at what? 1.33, I think. Hold on. Right. Question here. What's this here? I gave you a ray. The angle of incidence is 35 degrees. The refractive index 1.33. My question is, will total internal reflection occur? What's the first thing I have to look for here? Faith, yeah. Set your hand up there. What's the first thing we have to do here, Faith? What's I? What's C? Huh? What is C? What is called C? There we go. What do you do then? Right, C is the critical angle, right? So step number 1 is to find the critical angle. Did I not please? Step number 1, find the critical angle. Step number 1, find that critical angle. Right, so we get what? Sin inverse of 1 over 1.33. What is that? 40, 48.8. Very good, I'm quick. So, well, total internal reflection of curve. 5 physics, like quick on Ricardo. What do you think? Well, total internal reflection of curve. I is how much? Why it will happen? Why would it happen? Because C is more than I. Very good. So you see it, since I is less than C, or the other way around, anything you want. I is less than C, then total internal reflection will not occur. What might occur? Refraction. Right? Here we get that. Right? Good job. So refraction will occur, right? Jamian, you okay there?
Yes, sir.
Yeah. Keep it there. Good job. Right.
So you're losing marks on it if you don't put your statement and thing on.
Yeah, you need a statement. Right, I is less than C, so therefore total internal reflection will not occur. Right? So, yeah. So you recognize that he made that some medium, so it did work out, right? Yeah. He done here? He done? He done? He done. And Debian? Debian? Okay there? Let's go again. Anybody write it? Yeah. Right? Next one. Right? Do online message answer, right? Do online just message yes or no. Huh? Class, yes, sorry, class. Again. Second, just message yes or no, right? Just message yes or no. And if you can message why, that would be good too. Yeah. What's your gun? Kaya, what's your gun? Anything else?
So, maybe after like 1.8,
Huh? You do wrong the top, but you just have to highlight if it will happen or not.
Oh yeah,
Will happen. So how about yes? Where you get that? Huh? No. All I want to know is if total internal reflection will happen.
yes.
Yes?
Yes.
Teresa said no. Yeah? Yeah? If you get this one right, you'll get a chance. Where are you going with yes?
Honestly, I can't mix up. Just go okay.
Alright, so let's see.
I don't like this.
Right, critical angle is what? Critical angle is sine inverse 1 on.
1.5.
So the critical angle is approximately 42, right? 41.8. Right? And the angle of incidence is more than the critical angle. So that is satisfied, correct?
Yes.
And here is what? More than, so less than. Here is less than last. That does not satisfy. But therefore, no charge variable.
Sir, what's your plan? I have it in a book.
I give you a fair, that's a fair chance I give you.
Sir, come on, 5 minutes. This is like
Come here now. You were saying yes, I know.
No, but I said no first. I said no first.
You gotta stick with your answer. You almost give us some charge.
Look at my that's
No more charge.
Please, sir.
All right. So let's see if we can translate this to our part paper now, right? Right, online, you'll see why the answer is no. Supposed to be no here, right? Katrina, you'll see why it's no, right? Caleb?
Yes, sir, yeah, because of the air and how dense it is, the glass.
You have to remember that, right?
Yeah.
Right. So Katrina, although the angle of incidence was more than the critical angle, you have to make sure that it's in a denser medium. But it's in air. Air is less dense than glass, right? So that's the reason why total internal reflection did not happen. The two rules have to be satisfied. Right? These two rules here have to be satisfied, right? Rule 1 and 2. All right. Let's go to our little past paper here. Hold on. But let's make sure I do this good. What do you want from today or there? Atelier. You want today or what year? 19? All right, let's take a look at Jan 2019. Right, hurry up, we don't have much time. We don't have much time and we have 4 questions to do, so hurry up. Take a little read. Huh? One face. Have faith in yourself. Let's see it. Hurry up. Go ahead, diagram quick. See them. Don't distract them, please. Come on, hurry up. You have 3 parts, huh? That's just part 1. 2019 January. Right? What's your got? Right, so the question said what? Draw the part of the ray which meets the glass air boundary. The glass air boundary tells us that. Right. For the quick review, meeting members section. Meeting members. Meeting members, we have a hold on, I'm just trying to share it back and see if I can write on the PDF. Right. So first part, they said glass air boundary. So what direction coming from Ricardo? Ricardo, why did you not notebook? Oh, you can't notebook, question, right? Tanisha, when it comes to class, I don't want you all over the place. I want you in class or not in class at all. All right? Stay one place, another place. Right, yeah. You have air and glass, right? So, what direction are we going in? From here or from the glass to the air? We're going from glass to air. Okay? So that's what it's saying, right? So you're starting from glass and you're going to air. But here's what you want. The angle of incidence equals to the critical angle. So Elon, where do I draw that refracted ray? Angle of incidence is equal to the critical angle. Where do I draw that refracted ray? Huh? Inside? Where are you next side? Like the original going where? Like that? Question said equal to the critical angle. Huh? Right there. Huh? Equal to the critical angle. Beware. The back of the first node from today. 90 degrees from the normal. Right? 90 degrees. Okay, they wanted to label the incident ray. This is the incident ray. This is your refracted ray. Yes. Right? So that's what they want in part 1. What do they want in part 2? What do they want in part 2? What do they want in part 2? Tyrese online. Hold on, I'm trying to get that name. Kareem? Right, Kareem. What do they want in part 2? Kareem? What do they want in part 2 there? Critical angle, right? How do I find critical angle? Come on, the back of the formula. Sine inverse 1 on n. So that'll be sine inverse 1 over 1.5. You all work it out already. The answer is what? 41.8. 41.8 degrees Celsius or just degrees? Celsius. Okay, That is your critical angle, yes, sir.
Why last time?
What? I always said 41. 41.8 degrees. Next part. Any questions online earlier? I was just using the formula, right? Try this here, please. Sorry.
I'll stay at 6 o'clock.
Try this next part. Right, they say the angle of incidence greater than the critical angle. What will happen? What will happen? Henry? What will happen? If it's more than the critical angle, what will happen? Chanel or Sherelle? Sherelle, what do you think will happen, Sherelle? There's a new rate and it's more than the critical angle. What will happen? Okay, Sherelle? Yes? Not the bucket, I'm showing you yourself. I said they gave you a new ratio. Is it more than the critical angle? This new rate. Sure? Is that new angle more than the critical angle? Read the question. It's more than, right? And is the rate denser medium? Yes. Is it denser medium, right? So total internal reflection will happen. Okay with that? We are getting into any questions online? Damian, Nico, any questions?
No, sir.
All right. Let's go again. Next one. Okay, now. Okay, now let's go again. This is June 2021. June 2021. Okay. Right, forget the first part, right? And there's some definition. So you have a ray of light. A ray of light from air through a cube of ice along two rays. You have partial reflection and so on. You want to, in fact, draw a diagram first. Draw a diagram quickly. 2021. That's right. Oh yeah, draw a quick answer part one. You'll see part one there. But wait up. But join diagram, right? Join diagram. All right, and what's the angle of incidence here? How much? 59. You always measure your angle of the angles between what? The normal. Sorry. What's that? Between the normal and the ray, right? Hold on, Let's get this back. Sorry, yes. You'll see it now, right? So you measure it here, Darian, right? And that angle is 59, right? 90 minus 31, okay? Always measure your angle between the normal and the ray, okay? And that's the diagram. Let's move on. That's part one, I think. Part two, find the angle of reflection on the face MN. Hopefully you labeled the diagram correctly, right? So go back to your diagram and they want the angle of reflection. Here's 59, right? Where is the angle of reflection? I picked somebody online. Tyrese. Tyrese, where is the angle of reflection? Yeah. Somebody here. Two there. One there. Let's take one just in case, right?
Exams.
So we're looking for
Anybody else?
Now that's-
Exams, right?
Yes, Tyrese.
Okay.
What will be the angle of reflection here?
the angle of reflection. Really.
Yeah, reflection here. I think it will be.
Bring it back next week, guys.
So I don't have this one.
All right, anybody can help him? Malini, you can help him. What will be the angle of reflection? What's the law of reflection? Angle of incidence equal to angle of. So the angle there is what? 59. Okay, we have to do the angle of, right? 59. Correct, Katrina. 59, right? Add it to your diagram, right? So whenever you revise, take it out of the practice. Find the angle of refraction. They give you the refractive index. Find the angle of refraction. Quick. What's the formula we're going to? Alright, give me a minute. What's the formula we're going to use? I'm going to click on online for a while. Shannon. Shannon, search you. Shannon. Shannon, use your mic. I'm not seeing if you're sending a message. Use the mic there, Shannon. Yeah. Give me a chance to shine, grab. Free charge. What's the formula you're going to use to find angular refraction? Would trust them. Yeah, I think we get service so often. That's not.
I think get a call.
Yeah, yeah. Elon, what are you doing here? Sherelle, the right on the table, please. What?
I need to tell them before I cry here. Somebody else.
Yeah, Malachi. You said to use sign.
Guys,
I didn't hear that. So it's 1.31 times. How you solve this earlier? How you solve something like this? Richard, Katrina. How you solve Right, cross multiply and work it out. You can still put on your mic channel. So it's 1.31. Oh yeah, solve this please. Right, cross multiply and make sine R the subject of the formula. Oh yeah, hey. Right, sine inverse sine 59 over 1.31. 40.8 or approximately 40.8 or 40.9. No wrong, no. If you do wrong, though. You put an exact value. Put an exact value from another more again. 40.86. Exact 40.9. So the angular refraction is 40.9 degrees. You have to learn the transpose here earlier. When you have two fractions, cross multiply, and then carry across 1.31, and then carry across sine. That's why I have this. I did not work out anything, so I don't have to round off. Okay? This value here is 40.9. Selena again. Alright, no, we're not done. You have a next part. Right, please, you will answer that. Label on your diagram, label a critical angle for ice. On your diagram, label a critical angle for ice. Yeah. Where is that critical angle? Look at the wheels. Yeah, you gonna have it? No? Next to you done. You have it? Where is that critical angle? Last thing I'm done. I need to get that critical angle. Defina, I need that help.
So they keep it, right? Right, so
Right, yes, all here. Make a little guess. Look, what is critical angle again? When the angle of refraction is what? The back of the note. When the angle of refraction is 90. So look on that diagram and where you see in the angle of refraction is 90. Somewhere to put it. See if we can label very critical angle. And you know, right? Oh, yeah, try it quick. That's very good. Come on, it is the exact same diagram that we did a little while ago. There is the 90, right?
Yes. Yeah.
Oh, wait, up on there. There is your 90. So your 90 degrees is here. Right? Your 90 degrees is there. So therefore, here is your critical angle. Okay? The critical angle is there. Right, Ravi?
Yes, sir.
Did you add that to your diagram? Add that to your diagram, yes.
Oh, yeah, I did. Yes, sir.